So children, let's move on with the application part of coordinate geometry. That is to find out here in the first case the distance between two points. Here we have been given 3 pairs of points to calculate distance. Let's start with the first one. That is point A, 2, 3 and point B with coordinates 4, 1. We know what does A stand for? It stands for coordinate 2, that is x1, and coordinate 3, that is y1. X coordinate and y coordinate. So let's assign them. This is x1, y1, x2, y2. So let's calculate now and move on to find out distance AB, which will be given with the formula x2 minus x1 the whole square plus y2 minus y1 the whole square. Let's substitute the individual values of x1, x2, y1, y2. x2, if we can see, is 4. Let's not forget the square root sign. So 4 minus 2 the whole square plus y2, 1 minus 3 the whole square. To move on, first we calculate what is inside the bracket. In the first bracket, 4 minus 2 gives us 2, 2 square plus 1 minus 3 we know is minus 2 the whole square. So distance AB will be equal to 2 square, that is 4, plus minus 2 into minus 2 again gives me plus 4, plus into plus will again give me a plus. So distance AB will be equal to square root of 8. But is this the answer? No children. Let's change it into a surd, a mixed surd. Because we know root 8 can be written as 4 into 2 as a product of 4 into 2 and square root of 4 is 2. So 2 root 2 units is the distance between the points A and B with coordinates 2, 3 and 4, 1. Now children, let's move to the second problem with points T and R. Again here, we will have to use the distance formula. So let's start. To begin with, let's write down T with its coordinates minus 3, 6, R with coordinates 9, minus 10. Here again, T has coordinates x1, y1, R with coordinates x2, y2. To begin with, let's first write down the distance formula. That will be equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So let's substitute in this next step. What is x2? x2 is 9 minus x1 is minus 3. So I'll have to insert a bracket, minus 3. Or you can put a square bracket, the whole square. Plus, let's substitute the value of y2, that is minus 10 minus y1, that is 6. So y2 is minus 10 minus 6, the whole square. The next mathematical step will be to solve. Let's look inside the bracket first. Here we have 9 minus, now minus into minus, bracket when you open performs the operation of multiplication. So minus into minus is plus 9 plus 3 the whole square plus, let's see what we have inside the other bracket. Minus 10 minus 6 gives you minus 16 the whole square. Let's solve it. First bracket, 9 plus 3 gives me 12. 12 square plus minus 16 into minus 16 gives me plus 1, 256. So we get distance TR, which is equal to square root of 12 square plus 256. To move on it, children, here we have now distance TR will be equal to 12 square is 144 plus 256. So, the next step, distance TR will be equal to square root of 144 plus 256 gives us 400. Will this be the answer? No, we can still further solve it as. Now, 400, let's write it as a product of few terms, few numbers. We know square root of 400 will be 20 into 20, which gives us 400. Let's split up further. 20 can be written as 5 into 4 into 5 into 4. So, distance TR will be equal to 5 comes out once, 4 comes out once. So, the answer is 20. Distance TR is equal to 20 units. So children, in the last two steps, we can again see, instead of further splitting 20 as 5 into 4, again 5 into 4, directly square root of 20 into 20, we could have written that is equal to only 20 units. So distance TR, the answer is 20 units. What did we use? We just used distance formula. One more children, that is problem number C, to find the distance between L and M with the same formula. So first let's write down problem number C. L is minus 7 upon 2. Here we are having a fraction. So let's be careful when we solve it. N with coordinates 11 and 4. So again, minus 7 upon 2 is x1, y1, x2. And this is y2. So let's substitute. Distance LM will be equal to again x2 minus x1 the whole square plus y2 minus y1 the whole square. So distance LM will be equal to. Now let's be careful as we are going to involve a fraction when we substitute. X2 is 11 minus the value of x1. What is x1? Minus 7 upon 2. So let's insert a bracket. Minus 7 upon 2 the whole square plus y2. What is y2? 4 minus y1 is again 4 the whole square. So what did we do in this step? We just substituted the values of x1, y1, x2, y2. To continue with, here let's begin to solve the first bracket. 11 minus into minus is plus 7 upon 2 the whole square plus 4 minus 4 is 0, 0 square. So distance LM will be equal to. Your children, you have to use the LCM method to calculate the answer. So what do we have here, children? It is 11 upon actually 1. The LCM is 2. So multiply by 2 into the denominator. Same will be done in the numerator. Whatever you multiply in the denominator should be done in the numerator. Why are we multiplying in the denominator? Because in denominator the value is 1. It should be made equal to the LCM, that is 2. So 1 into 2 will give me 2. So numerator is also multiplied by 2. 11 into 2 is 22. Plus 7. What happens to plus 0 square? 0 has no value. So 0 square is 0. We need not write it. So ultimately distance ln will be equal to square root of 22 plus 7 gives us 29 upon 2. Now children, over here we found out the LCM. Over here we got 22 plus 7 upon a common number that is equal to LCM, the whole square. So over here 29 upon 2, the whole square is distance ln. Finally, here we move on to calculate distance ln equal to square root of 29 upon 2. The whole square means what, children? Square root of 29 upon 2 into 29 upon 2. So we are left with the answer of distance between the 2 points LM is equal to 29 upon 2. Let's move on to still further reduce it. 29 divided by 2. 2 ones are 2. 2 fours are 8. Carry 1. So point 14.5 units gives us the distance between the 2 points L and M. So children, what did we use over here? For all the 3 problems we used the distance formula, which was given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square.